Hey dear Christmas, welcome back to our Adventure series, and today we'll be talking about the giant star in the center of our solar system. Yes, the Sun. The Sun rises in the morning, giving much needed light in the land and species below it. It sets in the evening, leaving the darkness in the world. It even provides the heat and energy necessary for life to survive. The Sun is like a superstar in our sky, and people have been checking it out for a super long time, even way back in the ancient times. Astronomers still keeping their eyes on it and find out new cool stuff about the Sun, which is the boss of our whole solar system. Guess what? The Sun is not just a big ball of fire, it's actually a star. Hold on to your hats, because here's a fun fact. The Sun is the one and only star in our solar system. Yep, no other stars here, just the Sun doing its starting. But it's not like the stars we see twinkling in the night. Nope, the Sun is our very own special star. Did you know that the Sun is actually one of the smallest stars in our whole Milky Way? Even though it's a regular star, it's super important for us. Why? Because it's huge, and it's like a big bright light in the sky. Without the Sun, we wouldn't have the awesome life we have on Earth. Sun, the superhero of our world. Now let's talk about the distance of the Sun from the Earth. The Sun may be close to us compared to other stars, but it's still very far from the Earth, about 93 million miles. Although the Sun is so far away, it only takes sunlight about 8 minutes to reach the Earth. Do you know why? You got it! The light travels so fast, around 299,792,458 miles per second. Now let's talk about the size of the Sun. Even though it's not the biggest star out there, it's like a giant space because it's so massive. Imagine this. If the Sun were empty inside, you could squeeze in more than 1 million Earths. But wait! There's more. The Sun takes the crown for being the biggest thing in our solar system. If you gathered up everything, the Sun, the planets, the dwarf planets, comets, asteroids, and even the moons, the Sun would be the grand champion, making up more than a whopping 99%. Everything else, all those planets and space rocks, would be less than 1% of the solar system. Now let's talk about the Sun's fuel. Just like other stars, the Sun is like a giant gas ball, mostly filled with hydrogen, a bit of helium, and just tiny bits of other stuff. The Sun uses hydrogen to burn bright. Hydrogen is Sun's fuel. Just like food is our fuel and gasoline is the fuel used by automobiles. Now if you're wondering about hydrogen, it's a super sneaky gas because you can't see it. It's invisible. But here's the cool part. Hydrogen is everywhere in the universe, like the ultimate space traveler. In fact, it's the most common thing out there. Hold on to your spacesuits, because here's the mind-blowing fact. The Sun doesn't have a solid surface like Earth. Nope, it's not a big fiery ball you can walk on. Instead, it's like a giant ball of super hot swirly gases. Here's where it gets really exciting. The Sun is not just hanging out being all quiet and calm. Oh no, the Sun is a non-stop mover and shaker. There are cooler spots called sunspots, where it's like the Sun is taking a breather and then out of nowhere, boom! It throws out high-energy tantrums called solar flares, like the most epic fireworks show in the universe. Now let's talk about the orbit of the Sun. Do you know all the planets in our solar system, including our home Earth, orbit around the Sun? Now here's where it gets even more epic. Our entire solar system with the Sun and all the planets is a part of a bigger galaxy called the Milky Way galaxy. And get this, while it only takes Earth 1 year to complete a full orbit around the Sun, Scientists estimate that the Sun will take around 230 million years to complete one full rotation around the center of the Milky Way galaxy. Hey there, explorers! Let's take a moment to appreciate the star of our world, the Sun. Even though people have been studying the Sun for thousands of years, there's still so much to uncover. Mercury is the first planet from the Sun and the smallest in our solar system, only slightly larger than Earth's moon. Despite its proximity to the Sun, Mercury is not the hottest planet in our solar system. The title belongs to the nearby Venus thanks to its dense atmosphere. But Mercury is the fastest planet, zipping around the Sun every 87.97 Earth days. That's much closer than Earth is to the Sun. Mercury is classified as a terrestrial planet with roughly the same surface gravity as Mars and 1.5 times smaller than Mars. First up, let's talk about its physical characteristics. Mercury may be small, but it packs a punch. With a diameter of about 4,880 kilometers, it's the smallest planet in our solar system, with 0 moons and mass equals to 5.5% of the Earth. Next, let's discuss about the orbit and distance from the Sun. From an average distance of 58 million kilometers, Mercury is 0.4 astronomical units away from the Sun. 1 astronomical unit is the distance from the Sun to the Earth. From this distance, it takes sunlight 3.2 minutes to travel from the Sun to Mercury. Mercury has highly eccentric and egg-shaped orbit. It takes the planet as close as 47 million kilometers and as far as 70 million kilometers from the Sun, traveling through space at nearly 29 miles per second, faster than any other planet. Now let's dive into some cool features of Mercury. One unique aspect of Mercury is its surface. It's covered in craters much like the Moon. These craters were formed by meteorite impacts over billions of years, giving Mercury a rugged and mysterious landscape. And here's an interesting fact: Mercury has extreme temperatures. Mercury's surface temperatures are both extremely hot and cold because it's so close to the Sun. Its surface can reach scorching temperatures up to 430 degrees Celsius during the day. Oh, that's too hot to handle. Without an atmosphere to retain that heat at night, temperatures can dip as low as minus 180 degrees Celsius. Oh, that's too cold to handle. Despite its small size and harsh conditions, Mercury is a fascinating world worth exploring. Scientists have been studying Mercury up close, uncovering its secrets and helping us learn more about our solar system. Venus, named after the Roman goddess of love and beauty, is a dazzling planet. Venus is the second planet in our solar system and the third brightest object in the sky, after the Sun and the Moon. Venus is often considered as the hottest planet in our solar system. Venus is also classified as a terrestrial planet, similar to Mercury and Earth. It has a surface gravity that is roughly 91% of Earth's gravity, making it slightly weaker than Earth's. First up, let's talk about its physical characteristics. Venus is often called Earth's sister planet because it's nearly as big as Earth. With a diameter of about 12,100 kilometers, it's the third smallest planet in our solar system, with 0 moons and mass equals to 81.5% of the Earth. Venus is approximately consists of 96% carbon dioxide, 3% nitrogen, and 1% other gases. Now, let's discuss about the distance and orbit. Venus orbits the Sun from an average distance of 108 million kilometers or 0.72 astronomical units. From this distance, it takes sunlight about 6 minutes to travel from the Sun to the Venus. Let's talk about something fascinating about Venus. It has the slowest rotation of any planet in our solar system. A single day on Venus would be 243 Earth days long, longer even than a Venus year, which takes only 205 Earth days. Because of the planet's extremely slow rotation, sunrise to sunset would take 117 Earth days, and the sun would rise in the west and set in the east opposite of the Earth. All the planets rotate on their axis counterclockwise except for Venus and Uranus. Venus and Uranus rotate clockwise on its axis. Now, let's explore some of Venus's unique features. Venus is often called the morning star or the evening star because it's one of the brightest objects in the sky. But beneath its beautiful clouds lies a harsh environment. Venus has a thick atmosphere composed mainly of carbon dioxide, which traps heat and creates a one-way greenhouse effect. This extreme greenhouse effect makes Venus the hottest planet in our solar system, with surface temperatures reaching a scorching 462 degrees Celsius. Despite its harsh conditions, scientists continue to study Venus to learn more about its atmosphere and surface. Earth originated from the leftover particles from the formation of our Sun some 4.5 billion years ago. These particles were brought together by gravity to create pebbles, which subsequently formed boulders and finally the Earth. The Earth's internal structure differs seriously from its external appearance. Dividing the Earth in half would reveal its distinct layers: the crust, mantle, and core. The Earth's crust is the outermost layer of the planet and is relatively thin compared to the outer layers. The crust is where we find landforms such as mountains, valleys, and plateaus. Beneath the crust lies a mantle, which is the thickest layer of Earth, and occasionally magma from the mantle erupts onto the surface through volcanic activity. At the center of the Earth lies the core, which is divided into two distinct layers, the outer core and the inner core. This rocky mass is the third planet from the Sun. You probably already know a lot about the planet Earth because Earth is the planet where we live. Although it is the largest of the inner planets, the Earth is far smaller than the four gas giants that circle the outer edges of the solar system. It's close enough to the Sun to be warm unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation as the case with Mercury. The Earth is also the first planet when traveling out from the Sun to have a moon, and the only planet in our solar system to have only one moon. Because of its unique place in the solar system, Earth is home to phenomena that are unmatched in the universe. Earth is the only planet that is known to have liquid water on its surface, and to retain water in all its phases, liquid, ice, and gas, instead of having it evaporate into space or become permanently frozen. In contrast, other planets experience extreme in temperature. Some are too hot, leading to the evaporation of water into gases, while others are too cold, resulting in the freezing of water into ice. As a result, Earth stands out as a unique celestial body, capable of sustaining liquid water due to its favorable temperature range. Earth is situated approximately 93 million miles or 150 million kilometers from the Sun. Surprisingly, the Earth has plenty of water, with oceans covering more than 70% of its surface. This enormous body of water is more than twice as large as all the Earth's land. As a result, Earth is frequently referred to as a blue planet. Liquid water is what allows life to exist on Earth. As far as we know, Earth is the only world known to harbor life. Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plant, animal, bacteria, fungi, and others including us call planet Earth home. The liquid hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. Earth's atmosphere is a layer of gases that surrounds the planet and is held in place by gravity. It consists of 5 major layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere, each with distinct characteristics. The Earth's atmosphere serves as a crucial aspect of our planet. It comprises a dense layer of gas covering the entire globe, primarily composed of nitrogen and oxygen. In addition to making breathing easier for humans, this atmospheric layer keeps the planet warm by insulating against heat from the sun. Additionally, it shields Earth from harmful solar radiation and incoming meteors. Objects entering the atmosphere undergo friction with its gases, often burning up entirely before reaching the surface, ensuring our safety from potential impacts. Earth's rotation and revolution are fundamental astronomical phenomena that define its motion in space. Earth rotates on its axis, causing day and night as different parts of the Earth's surface are either facing towards or away from the sun. Earth completes one rotation approximately every 24 hours, creating a day and night cycle. Earth revolves around the sun in an elliptical orbit. This revolution, along with the different tilt of Earth's axis, causes a change of seasons. As Earth orbits the sun, different parts of the planet receive varying amounts of sunlight, leading to seasonal variation in temperature and weather. Earth takes approximately 365 days and 5 hours to complete one orbit around the sun, which defines a year. We value the Earth since it is where we live. Together with millions of other plants and animal species, there are currently 7 billion people on the planet. It is critical that we care for the planet we are currently living in. Since as of today, we have not discovered another planet in the entire cosmos that would be a suitable home for mankind. Mars, named by Romans for the god of war, is a captivating world with its own unique mysterious and allure. Mars, one of the most explored bodies in our solar system, is a dusty, cold desert with a very thin atmosphere. Do you know why Mars is often referred to as a red planet? It's due to the presence of iron mineral in its soil, which undergo oxidation, leading to the characteristic reddish appearance of its surface. Mars is roughly half the size of Earth, with a diameter of about 6,792 kilometers. Mars has two small moons, Phobos and Deimos, that may be captured asteroids. They are potato-shaped because they have too little mass for gravity to make them spherical. Phobos, the innermost and larger moon, is heavily cratered with deep grooves on its surface. Deimos is about half as big as Phobos and is covered in loose dirt that often fills the craters on its surface, making it appear smoother than Phobos. Mars orbits the Sun from an average distance of about 228 million kilometers, which is roughly 1.5 astronomical units away. That's about half as far from the Sun as Earth. From this distance, it takes sunlight 13 minutes to travel from the Sun to Mars. As Mars orbits the Sun, it completes one rotation every 24.6 hours, which is very similar to one Earth day. A year on Mars lasts 669.6 solar days, which is the same as 687 Earth days. Mars' axis of rotation is tilted 25 degrees with respect to the plane of its orbit around the Sun. This is another similarity with Earth, which has an axial tilt of 23.4 degrees. Like Earth, Mars has distinct seasons, but they last longer than seasons in Earth since Mars takes longer to orbit the Sun. Mars has a thin atmosphere composed mainly of carbon dioxide, about 95.3%, with traces of nitrogen and argon gases. Mars' thin atmosphere doesn't offer much protection from impacts by objects such as meteorites, asteroids, and comets. While not as extreme as Mercury's, Mars experiences significant temperature variations. The temperature on Mars can be as high as 20 degrees Celsius or as low as about minus 150 degrees Celsius. Mars is popular for its diverse landscapes, including including vast plains, towering volcanoes, and deep canyons. One dominant feature is Olympus Mons, the tallest volcano in the solar system, which rises about 21 kilometers above the surrounding plains, higher even than the world's tallest mountain, the Mount Everest. Despite its harsh conditions, Mars has long fascinated scientists and explorers alike. Over the years, numerous missions have been sent to study Mars up close, uncovering its secrets and paving the way for future exploration. Jupiter, being the biggest planet, gets its name from the king of ancient Roman gods in the worlds of extremes. It's also the oldest planet, forming from the dust and gases left over from the Sun's formation 4.5 billion years ago. Jupiter is often referred to as the gas giant due to its gaseous composition. It is composed mainly of hydrogen and helium, similar to the composition of the Sun. Jupiter's signature stripes and swirls are actually cold windy clouds of ammonia and water, floating in an atmosphere of hydrogen and helium. The dark orange stripes are called belts, while the lighter bands are called zones, and they flow east and west in opposite directions. Jupiter's iconic Great Red Spot is a giant storm bigger than Earth that has raged for hundreds of years. Jupiter is truly a giant among planets, with a diameter of about 139,822 kilometers, more than 11 times that of Earth. Its huge size grants it a powerful gravitational pull. Jupiter has an impressive collection of moons, with over 80 natural satellites discovered to date. Among its many moons, 4 large ones, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons. Jupiter orbits the Sun at an average distance of about 778 million kilometers, approximately 5.2 astronomical units away. From this distance, it takes sunlight 43.3 minutes to travel from the Sun to Jupiter. As Jupiter completes its orbit, it rotates on its axis with a remarkable speed, completing one rotation in just under 10 hours. Jupiter's axial tilt is relatively small, as just over 3 degrees, resulting in minimal seasonal variations compared to a planet like Earth. Jupiter's atmosphere is a dynamic realm of swirling clouds and turbulent storms. Despite its volatile atmosphere, Jupiter's immense size and strong magnetic field offer a degree of protection to its moons, shielding them from the full force of solar radiation and cosmic rays. Jupiter's magnetic field is among the strongest in the solar system, generating intense radiation belts that pose significant challenges to spacecraft and exploration missions. Jupiter has been a target of fascination for astronomers and space exploration missions for centuries. From early telescopic observations by Galileo to modern spacecraft missions like NASA's Juno, our understanding of Jupiter has evolved significantly over time. Saturn, named after the Roman goddess of agriculture, is a marvel to behold. Its iconic wings, made up of countless particles of ice and rock, give Saturn its distinctive appearance. Saturn, like Jupiter, is a gas giant, mainly composed of hydrogen and helium, with traces of other gases and compounds. However, what sets Saturn apart is its magnificent ring system, consisting of icy particles ranging in the size from tiny grains to enormous chunks. Saturn's rings are thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. With a diameter of about 74,896 miles, Saturn is 9 times wider than Earth. From an average distance of 886 million miles, Saturn is 9.5 astronomical units away from the Sun. From this distance, it takes sunlight 1 hour and 20 minutes to travel from the Sun to Saturn. Saturn's impressive collection of moons includes Titan. Titan is the largest moon of Saturn and the second largest in the solar system. It is the only moon known to have an atmosphere denser than the Earth's, and is the only known object in space other than Earth on which has clear evidence of stable bodies of surface liquid. Despite its vast distance from the Sun, Saturn has the second shortest day in the solar system. One day on Saturn takes only 10.7 hours, and Saturn makes a complete orbit around the Sun in about 29.4 Earth years. Its axis is tilted by 26.73 degrees with respect to its orbit around the Sun, which is similar to Earth's 23.5 degrees tilt. This means that, like Earth, Saturn experiences seasons. Saturn's atmosphere is a stormy place of swirling clouds and powerful storms. While it lacks the intense storms of Jupiter, Saturn still experiences atmospheric phenomena such as the Great White Spot, a massive storm system that appears roughly every 30 years. Saturn has captivated astronomers and space explorers for centuries. From early telescopic observations by Galileo to groundbreaking missions like NASA's Cassini-Huygens spacecraft, our understanding of Saturn and its rings has deepened over time. Uranus, named after the Greek god of the sky, is a world covered in mystery. This distant giant, the seventh planet from the Sun, holds many secrets waiting to be unveiled. Uranus is often referred to as the ice giant, mainly composed of hydrogen and helium, along with water, ammonia, and meteor ices. Unlike the gas giants, Uranus has a distinct bluish-green hue due to the presence of methane in its atmosphere. With a diameter of about 31,763 miles, Uranus is 4 times wider than Earth. From an average distance of 1.8 billion miles, Uranus is about 19 astronomical units away from the Sun. From this distance, it takes sunlight 2 hours and 40 minutes to travel from the Sun to Uranus. Uranus has 28 known moons. All of Uranus' inner moons appear to be roughly half water, ice, and half rock. The compositions of the outer moons remains unknown, but they are likely captured asteroids. Uranus has 2 sets of rings. The inner system of 9 rings consists mostly of narrow dark grey rings. There are 2 outer rings. The innermost one is reddish like dusty rings elsewhere in the solar system, and the outer ring is blue like Saturn's E-ring. One day on Uranus takes about 17 hours. Uranus makes a complete orbit around the Sun in about 84 Earth years. Uranus is the only planet whose equator is nearly at a right angle to its orbit, with a tilt of 97.77 degrees, causing Uranus to have the most extreme seasons in the solar system. Uranus is also one of just 2 planets that rotate in the opposite direction than most of the planets. Venus is the other one. Uranus' atmosphere is a cold and dynamic environment, with temperatures dropping as low as minus 224 degrees Celsius, makes it even colder than Neptune in some places. The extreme cold combined with its unique axial tilt leads to complex weather patterns and atmospheric phenomena. Uranus has captivated the imaginations of astronomers and space explorers since its discovery in 1781 by Sir William Herschel. Since then, various space missions have provided invaluable insight into this distant ice giant. From flybys by Voyager 2 in 1986 to proposed future missions like NASA's Uranus Orbiter and Probe, humanity's quest to unlock the secrets of Uranus continues. Neptune, named after the Roman god of the sea, was the first planet located through mathematical calculations. Neptune is often referred to as the blue giant or the azure jewel due to its striking blue hue and majestic presence in the outer reaches of the solar system. Neptune, like its sibling Uranus, is classified as an ice giant with a composition mainly of hydrogen and helium, along with traces of water, ammonia, and methane. With a diameter of approximately 30,775 miles, Neptune is just slightly smaller than Uranus, making it the 4th largest planet in the solar system and about 4 times wider than Earth. From an average distance of 2.8 billion miles, Neptune is 30 astronomical units away from the Sun. From this distance, it takes sunlight 4 hours to travel from the Sun to Neptune. Neptune, having a fascinating array of moons, currently numbering at least 16 known satellites. Among these, Titan stands out as the largest, exhibiting a strange retrograde orbit, an orbit in the direction opposite to its planet's rotation. Titan is thought to have once been a dwarf planet, captured from the Kuiper belt into Neptune's orbit. The planet is encircled by a system of faint rings, composed primarily of dust and debris. Neptune has at least 5 main rings and 4 prominent rings arcs that we know so far. A day on Neptune lasts about 16 hours. While the planet completes a single orbit around the Sun in approximately 165 Earth years, equivalent to over 60,000 Earth days. Neptune's axial tilt, though not as extreme as Uranus, still contributes to the planet's dynamic and ever-changing weather patterns, resulting in captivating storms and atmospheric phenomena. Despite its great distance and low energy input from the Sun, Neptune's winds can be 3 times stronger than Jupiter's and 9 times stronger than Earth's. Neptune was discovered in 1846 through mathematical predictions by Orville Leverrier and John Gallier. The Voyager 2 spacecraft provided humanity's first up-close glimpse of Neptune and its moons during a historic flyby in 1989, unveiling a world of unparalleled beauty and complexity. Future missions, including proposed orbiters and probes, hold the promise of further unraveling the mysteries of this distant ice giant, ensuring that Neptune remains a focal point of scientific curiosity and exploration for generations to come.